Hi, we're going to continue with our HPC kitchen videos. So I'm going to start with a question. So if counter space is good, as you can see here, if counter space is good and convenient, why don't you buy a huge counter that can store everything you need in your kitchen and then do away with all the cabinets? So I proposed a question like this and it seems sort of obvious, because if you could go and buy the biggest counter you want, why not buy a smaller counter but then get a lot more shelf space? So this is exactly the same trade-off that's made with data storage and so on. So you'd think, okay, we should have one data storage system that does everything. It's big, it's fast, it's attached to the cluster, it's backed up and whatever, but it costs a lot to satisfy all of these. So in practice, anytime something gets big enough, it's divided into different purposes. There's one that's safe and backed up. There's one that's fast and attached to the cluster. There's one that's really big for archival data, and so on. So basically, if you're doing big scientific computing work, you're going to have to learn to deal with multiple different data storage places and combine them together for your work. Let's go over some jargon. So first off, there are files. This is basically data that's stored. So in my metaphor, the data is all of the different, food items we're using to cook. Then there's the word file system. So this is what's referred to as the total structure, like how the files are all presented, all the folders and directories, things like that are there. Then there are paths. So a path to a file is the string that identifies where it's located on the computer. And finally, there's a word you sometimes hear called mount. So a mount is sort of the attachment of a data storage place into the file system. So the word comes from when they had things like physical drives and things like that, cassettes or whatever it was back then. And they would physically take it and mount it into the drive holder in order to access the data on it. So anyway, that's that. Okay, so let's go over a typical hierarchy. So there's different types of things that are distinguished by how large they are, how fast it is to access, and so on. So I'm mainly talking about speed right now, but it typically goes, the faster something is to access, the smaller it will be. So for example, right here by the stove, which in this metaphor is the processors, there's a little bit of counter space, which we consider the processor cache or main memory. We go a bit further away and there's more counter space. Oh, hello. We go a bit further away and there's more counter space, and I'll call this like the memory. We go up and we get things like the cabinets, which are a little bit harder to access. The fridge. Then we can come to like the storage places where I store food here. And we can even look at network attached storage. So that would be, for example, there's some stuff that I could use that's still in the grocery store, and I have to actually go and travel to get it and bring it to this kitchen when I use it. Okay, so how does this work in a computer? So in a computer, there's usually stuff that's right close to the processor cache. This is on the order of, well, the first level cache is maybe tens of kilobytes and goes to hundreds of kilobytes, then megabytes in modern processors. Then we get to things like the main memory, and that is, well, larger. So on modern computer, it's on the order of size of gigabytes, tens of gigabytes. Then we get to things like SSD drives. So SSD drives don't have moving parts in them. It's what's called flash storage. And that is, sorry, again, I'm distracted, but it's a very welcome distraction. We have an investigator of the kitchen's storage areas looking for good data to eat. Okay, where was I? So SSD drives, they don't have moving parts, so they're all electronic, and data can come off of there pretty quickly. Then there are hard disk drives like this, which, since it actually has a spinning platter inside of it, that stores things, it actually has to wait until it can spin and get the right data area under the reading head to be accessed. So it's the slowest. And then there's network storage. So actually network latency isn't necessarily that much compared to the latency of accessing from a hard drive, but it depends on every storage system, what it is, and so on. So how are these files organized? Let's go over the file system hierarchy. So in Unix, Linux, Mac computers, it's not organized by drive letters. It's organized by, well, just strings. So it starts off with slash or root. And this means like, well, the root of the file system. So all paths can start with a first slash like this. And let's put this up for, you know, the whole kitchen is somehow contained within slash. Actually, not the memory, but okay, yeah. Then we have subdirectories there. For example, we have cabinets. So let's put cabinets up. Well, where do I put them? Oh, let's see. Will it stay here? Yes. Okay, cabinets. So this is slash, as in the root of the file system, cabinets. And we can go down deeper. There's slash cabinets slash 1. So let's say this is the first cabinet. Slash cabinet slash 2, the second cabinet. And so on and so on. So if you've dealt with computers and file storage paths, this much will be familiar to you. So every type of computer organizes things like this. Some call it directories, some call it folders, but it's all the same idea. And it goes on deeper. So for example, inside the cabinets, we have cabinets 1 top, cabinets 1 middle, cabinet 1's bottom, and so on. Okay, so again, there's no drive letters on Linux, Unix, Mac kind of computers. Okay, so what happens when we need to move data from somewhere to somewhere? So the first and easy option is to transfer. So you use a program that copies data from one place and moves it to another computer, probably over the network. So that's simple. You take, copy, and we've moved it. You've probably done this many times. You're uploading to a cloud storage thing, downloading from cloud storage, moving things with SSH to the cluster, whatever it may be, like that. And it works fine. So the disadvantage is that it's something you have to do yourself and that it makes 2 copies. So if you start modifying the 2 copies separately, then you might get in a big mess where you have to keep them synchronized. By the way, this is what version control is used for, but that's not the topic right now. Okay, yes, but there's another option, and this is actually used all the time on these computers, and that's called file system mounting. So like I said, mounting is making something available, but it's not just about physical disks. You can mount things over the network. So for example, in most clusters, all the computer nodes, all the login node where you're doing the computation and so on, it all looks like it has the same files. That's not because they're transferred everywhere. They're actually stored on some separate file system and it's available somewhere else. So on a Unix type computer, for any of these file system places, you can do a file system mount and put something else there. So let's take an example. I have some server, data.university.fi, and I want to mount it under cabinet /1. So I, as the administrator of the cluster, type some commands and then makes this available here. So then what happens inside of that cabinet? So from the user point of view, it looks the same. It just looks like a place on disk, but actually something happens. So let's see if this demo sort of works. So once it is mounted and the user looks inside, it actually is from a different server. So here, this is project 1 on that server, project 2, project 3, and so on. And we can thus then see that data there. And this can be sort of confusing. So as a user, whenever you go and are accessing different things, it's not always obvious what data is stored where. It looks like it's one computer, but it's really scattered among all these different things. If the administrators are trying to do you a favor and making data all available on the same computers by mounting all these different file system storages in one place for your convenience, well, then you have to keep track of it. So it's actually a little bit more mental load for you. Okay, there's one more thing I'd like to talk about. So this is the idea of working directory. So whenever you're writing a recipe for doing some cooking, you don't just say, take this ingredient, take that ingredient. You have to say where the ingredients are, as in you have to give the file paths to each ingredient or data that you're mixing up. And you don't want to go giving the full path to every bit of data. You don't want to go, it's /cabinet/1/project1 and whatever. Because this can be different. On different computers, the data at university.sfi server might be mounted in different places. Or you might have different personal directories on different clusters. So we use something called the working directory. And that's like where you take every process, like every cook, you tell it, okay, right now I want you to move to this working directory. And then everything in the recipe, all the code, is relative to that directory. So instead of saying, take this whole file path, you say, from relative directory, top/input data, open the file and read it and save it to bottom/output data, and so on. Okay, and this is something which is often used in projects, but I've never really seen it explained well to people. So this is my initial attempt, but it's something that you will keep an eye out for, and hopefully it will become more clear later. Okay, with that being said, I'm done with this talk. So what comes next? So I've introduced the idea of this file system hierarchy here and all these data storage things, but it's up to you to figure out how it works on your particular cluster, on your computer, wherever you're working. And you need to make some sort of a mental map of where all these things are and what are the properties of these. This might be really fast to access. When I look in here, it's a portal to another server, and that's slower to access, and so on. And this can be hard to figure out. I must say, even on our cluster, even though we have a table of what all these things are, really maybe we can make it more clear somehow to new users. Anyway, we'll be working on that, and hopefully you can work on reading and understanding these things. Thanks a lot. Bye.